Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2023. Paper 3, FoundationTier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1a, solve 5x equals 15. So we've got a linear equation here, quite a simple one. I've just got 5 lots of x and I want x. So to do that, I'm just going to divide both sides by 5. So 5 divided by 5 just gives me x. And then 15 divided by 5, that's 3, isn't it? So x is equal to 3. Part B says solve y plus 7 is equal to 50. Again, this is quite a simple one. We just need to take 7 away from both sides, don't we? They'll cancel. Leave me with y is equal to 43. That's my answer there. And then finally I got c over 4 equals 8. This is another simple one-step equation. Just need to multiply both sides this time by 4 because multiplying by 4 is the opposite of dividing by 4. Again, they're going to cancel, leaving you with just c is equal to 4 lots of 8, which is 32. So c is 32. Question 2. Here is a list of numbers 10, 8, 2, 11, 12, 15, 4, 4. Write down the mode. Okay, well, mode is most, and I can see already that there are 2 4s, which is more than all the others, isn't it? Because all the others just appear once. Okay, so because 4 appears twice, which is more than any other number, that must be the mode. Now, the median is the middle number, but only after we've got them ranked from smallest to biggest, and these are not. These are kind of just jumbled up, aren't they? So the first thing I'm going to do is rewrite that list in order of size, smallest to biggest. So the smallest number in that list is 2. Then I've got a 4 and a 4. What's next? 8. Then I've got a 10, 11, a 12, and a 15. I kind of write them down under the original numbers, and that kind of keeps track of how many I've done then. I know if I've got them all. So, okay, so what's the middle one now? Now, I've got an even number of numbers. So, to find the middle one, you add 1, you divide by 2. So, 8 plus 1 is 9, divided by 2 is 4.5. So, it's the 4.5 value. Okay, so which is the 4.5 value? First, second, third. This is the 4th. This is the 5th value. So, the 4.5 value is kind of halfway between the two. We're kind of averaging out these two numbers here in the middle. So, what is the average of 8 and 10? Again, you can just add them together and divide by 2. That's going to give me 9, isn't it? So that is the median. So the median is 9. Range, highest minus lowest. So range is the highest value minus the lowest. Now in this case, the highest is 15 and the lowest is 2. So 15 take away 2 gives me a range of 13. Question 3a. A fair spinner with 5 sections is spun. Complete these statements. The spinner is most likely to land on section, well, it's most likely to land on the biggest one, isn't it? And that's going to be D. So D is the one that's going to most likely land on, and the spinner is equally likely to land on sections blank, and blank. So which ones, if it's going to be equally likely, then their size is going to be the same. Now they're all different sizes apart from these two. These two are the same size, aren't they? So E and A, they seem to be the same size to me. You could measure them with a protractor if you weren't sure, but I'm pretty sure it's those two that are equal to each other. So I'm going to go with A and E. Part B says two different spinners are spun. One spinner has sections labelled with colours and the other spinner has sections labelled with numbers. Here is a list of all the possible outcomes. So you could get red 1, red 2, red 3, red 4, blue 1, blue 2, blue 3, blue 4, green 1, green 2, green 3, green 4. Show the possible sections on the two spinners. Okay, now it doesn't say anything about frequency, but I'm just going to divide these up into thirds and quarters. So I've got three different possible colours. I can have red, blue or green. They're the possible colours, aren't they? So you can see that as appearing there, 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 there and there. So it's all red, red, blue, green each time. And I've got four different possible numbers. I've got 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to divide up the colour one into three sections. I'm going to label one red, one blue, one green. Now you don't really need to measure these. It doesn't say that it has to be accurate or reflective of any particular number. So I'm just going to kind of roughly draw thirds though. I know what thirds look like. They're about like that, but I don't have to get my protractor out or anything to draw them properly because that's not what this question is about. Okay, so I'm going to have one section that is red, one section that is blue, and one section that is green. And then on the other one, I'm going to have to accommodate four numbers, aren't I? So I'm going to have to divide this one into quarters in order to accommodate those. So a line straight across the middle, and then extend this other one down to make 4 quarters. Okay, and then I can then number those 1, 2, 3, and 4 then. So 1, 2, 3, 4. Okay. Question 4. A reel holds 9.5 meters of ribbon. 2 pieces of ribbon are cut from the reel. Each piece is 20 centimeters long. What length of the ribbon is left on the reel? State the units of your answer. Okay. So just note here that we got two different units, didn't we? This one is in meters and this one is in centimeters. So in order to do the maths, we really need them in the same unit, and I think it's probably easier to convert the meters into centimeters because then I can deal with whole numbers and not decimals. So how many centimeters are there in a meter? Well, 1 meter is 100 centimeters, isn't it? Centi means 100. Century is 100, isn't it? So anyway, so 9.5 meters times that by 100, that's 950 centimeters, isn't it? So the ribbon is 950 centimeters long. The ribbon cut is 2 lots of 20 centimeters, which comes to 40 centimeters. So ribbon remaining then, that's going to be 950 minus 40. So that's 910 centimeters left. Okay, so 910 centimeters. Now it does say state the units of your answer. So if you do not do that, you will be losing a mark. So I definitely will be doing that. 910 centimeters. Question 5a, the term-to-term rule for a sequence is subtract 1 and then multiply by 5. The first term is 4, work out the third term. Okay, well we're going to have to, because this is a term-to-term rule, we're going to have to work out the second term first. So I've got u1, the first term is 4. u2 is going to be u1, the first term, 4, subtract 1 and then divided and then multiplied by 5. Now I just need to take care with this because actually you're multiplying the whole thing by 5, so it's actually 5 lots of 4 minus 1 if you think about it. I need to write it in with a bracket like that because I'm doing the subtraction first and then I'm doing the multiplying. So 4 minus 1 is 3, and then 3 times 5, that's 15. So that's my second term. So my third term then is going to be the same thing, but instead of 4 in the bracket, I'm going to have 15. Okay, so it's going to be 15 minus 1 and then times by 5. So 15 times minus 1 is 14, and 14 fives, that's 70, isn't it? So my U3, my third term, is going to be 70. Part B says, I've got a different term to term rule here. This time it's add 20 and then divide by 2. We've got the second term is 50. You want to work out the first term. Okay, I think we're just going to think this is a bit of a function machine. So I've got a number going in, we're adding 20, and then we're dividing by 2, aren't we? Okay, now if the output was 50, I want to go back to the input then, don't I? I want to know what fed in, what was the first term, so that when I did that to it, I got 50. Okay, so just kind of following this backwards. A number was divided by 2 and I got 50. So in the mid stage here, I'm guessing it was 100, because 100 divided by 2 is 50. And then something plus 20 was 100. That must have been 80 then, mustn't it? Because 80 plus 20 is 100. So that's it, isn't it? So if I put 80 into this function machine, I add 20, I get 100, divided by 2, I get 50. So that means that the first term must be 80. Question 6. Scarlett leaves home at 10 to cycle to a supermarket. Here is the part of the distance time graph for a trip to the supermarket. So we've got the time along the bottom. Look, she's leaving at 10, and then at 10:20 she's arriving and stopping for a while. Okay, so you can see in part A it says she arrives at the supermarket at 10:20. That's what we just noticed. How far is the supermarket from her home? Well, she's travelled for 20 minutes to 10:20. So you can see the height of this line at this point is here. Look, that's, what's that? That's about 7, isn't it? So she's travelled 7 kilometres from her home at that point then. So she's gone 7 kilometres. That's a long old bike ride. Okay, and then she leaves the supermarket at 10:35. How long does she stay at the supermarket for? Well, she stays at the supermarket from this time, which was 10:20, to this time, which was halfway between 10:30 and 10:40. It's going to be 10:35, isn't it? It's 10:35. So if she arrived at 10:20 and she left at 10:35, then how many minutes is in between? That's 15 minutes, then, isn't it? So how long did she spend at the supermarket? She spent 15 minutes. Part C says Scarlett cycles home at a constant speed using the same route. It takes her 3 minutes longer than the journey to the supermarket. Complete the distance time graph. Well, she took 20 minutes, didn't she, to get there? So on the way home, it's going to take her 23 minutes. So what is 23 minutes after 10:35? So 10:35 add 23. That is 35 plus 23, 45, 55, 58. So she's going to be arriving at 11:58. Okay? Now you've got 10 squares between 10:50 and 11. So 58 is going to be that point there then, isn't it? Okay, 2 little squares in from 11. So all we really need to draw, if she's travelling at constant speed, we're just going to be drawing a straight line down from the point where she left down back home again to 11 o'clock. Like that. Okay, job done. Question 7. This week, Liam works 25 hours at £10.20 an hour and extra hours at the weekend at £11.80 per hour. Here are the extra hours he works at the weekend. So he worked from 7 till 10 on Saturday and he worked from 1 till 3 on Sunday. In total, how much is he paid for the week? Okay. So we're going to do this in 2 parts. We're going to work out his normal pay for his normal hours, and then we're going to work out his overtime, his extra hours that he worked at the weekend, and we're going to add them together, and that will give us our total, isn't it? So let's do his normal pay first. This is his normal pay. So he normally works 25 hours, and he's paid at £10.20 an hour. So what's that then? So we just need to type that into the calculator, don't we? 25 times £10.20. 25 times £10.20, that comes to £255. So he's earning £255 normally. Then he's got his extra pay. So how many hours is that then? Well, 7 a.m. to 10 a.m. 7, 8, 9, 10. That's 3 hours, isn't it? He's working 3 extra hours on Saturday, and 1 p.m. to 3 p.m., 1, 2, 3, it's 2 extra hours there, isn't it? So altogether, he's worked 5 extra hours over the weekend. So it's going to be the 5 extra hours he worked multiplied by his weekend rate, which is £11.80. Seems a bit stingy to me for overtime. But anyway, it's normally time and a half. That is not very good. It would not tempt me to come in on a Saturday. That's £59. £59 then. So then the total pay is going to be those two added together. So the 59 plus 255, that comes to £314. Okay, so then how much is his pay for the week? It's £314. Okay. Question 8. 3 oranges have mass 60 grams, 70 grams, and 85 grams. Show that their total mass is between a fifth and a quarter of a kilogram. Well, let's work out their total mass first. What is their total mass? That is the 3 things added together. That's 60 plus 70 plus 85. And that comes to 60 plus 70 plus 85. That comes to 215 grams. Okay. Now I want to show that as a fraction of a kilogram. Now 1 kilogram is 1,000 grams, isn't it? Okay. So then as a fraction, that's going to be 215 grams over 1,000 grams. Okay. So how can I show that that's between 1/5 and 1/4? Well, I suppose what I can do is I could take a fifth and a quarter, I can rewrite it as equivalent fraction over the same denominator. Mind you, that one might simplify yet. Let's just type that into the calculator and find out. So 215 divided by 1,000, that's going to cancel because they both end in 5s. So that's 43/200. Okay, so then what I'm going to do is I'm going to rewrite 1/5 as a fraction over 200, and I'm going to rewrite a quarter as a fraction over 200, and then I'm going to see that 43 lies between them. So 5 goes into 200 how many times? About 40 times, isn't it? So that's going to be 40 200ths, and 4 goes into 250 times, so that's going to be 50 200ths. So you can see then that 43 lies between 40 and 50, so it does work. So I'm just going to say that 40 over 200 is less than 43 over 200, which is less than 50 over 200. Okay, so that does work, doesn't it? So it does lie between. So yes, it lies between a fifth and a quarter. Question 9. For each statement, tick the correct box. Is it always true? Is it sometimes true? Is it never true? One of the 3 angles of a triangle is 90. Well, it's not always true, is it? Because you can have a scalene triangle which was, I don't know, 40, 60, 80. That would be a perfectly fine triangle, but it wouldn't have a 90-degree angle. Although you can very much have right-angled triangles. So I'm going to say that that one is sometimes true. Okay? So I can have a right-angled triangle. That would be true. I could have an equilateral triangle. That would not be true. Okay, so I can find examples of both. Part B says one of the 3 angles of a triangle is obtuse. Now, can I draw one that is obtuse? Well, I could, couldn't I? So like a big angle like that, that's an obtuse angle. So I can draw one that is obtuse. But again, I could have an equilateral triangle which is 60, 60, 60, and none of those are obtuse, so I can draw them both with and without an obtuse angle, so I can say it's sometimes true. And then one of the 3 angles of a triangle is reflex. Not sure that's going to work, is it? Because if I have an angle like that, then the only way I can join up those 2 lines together is here, and that doesn't work, does it? I can't join them up around like that. So that is never true. Can't have a reflex angle in a triangle. They only add up to 180, isn't it? A reflex angle starts at 180, so you know it's going to be like you can't have 200 and something adding up to 180. It doesn't work. So that one is never true. 10a, simplify fully. P squared times p. Well, p squared is p times p, isn't it? So I've got p times p there, and I'm timesing it by another p. So I've got p times p times p, so that's p cubed. 10b, simplify fully, 3a plus 5c minus a plus 6c. So collecting like terms here. I've got terms in a, there and there, and I've got terms in c, here and here. So adding the a ones together, well, I need to subtract actually, because I've got 5a plus negative a, which is 5a. Take away a, that's going to give me 2a, and I've got 5c plus 6c, well, that's 11c. So that's giving me 2a plus 11c. Question 11, two angles around a point are shown. The angles are in a ratio of 2 to 7. Show that the large angle is 280. Now this is a bit like a dividing by a ratio question, isn't it? Because I've got these two angles that make up a full turn. So this one and this one together make a full turn. And a full turn is 360 degrees. So essentially what I'm doing is I'm dividing 360 degrees in the ratio of 2 to 7. So it's a divided by a ratio problem. So 360 in the ratio of 2 to 7. Right, if I've got the ratio of 2 to 7, that means I've got 2 shares and 7 shares. So altogether I've got 9 shares. 2 plus 7 is 9. Okay, so what's the value of each one of those shares? Well, I've got 360 degrees and I'm dividing it into 9 shares. So 360 divided by 9, I think that's 40. I'm just going to double check. Yeah, that's 40. So 360 divided by 9 is 40. So 40 degrees for each share. So then if I take my ratio of 2 to 7 and I scale it up by a factor of 40, then 2 lots of 40 is going to be 80. And 7 lots of 40, well, that's going to be 280. That's what I was looking for. Okay, so I've shown it then, isn't it? So it's going to be 80 degrees and 280 degrees. 12a, I've got c is greater than 4, d is less than 4, and c minus d is equal to 6. Work out a possible pair of values for c and d. Okay. Well, I want c minus d is equal to 6. I just want to keep things positive. So that means c is essentially, if I'm going to keep things, but it doesn't have to be because I could have negative values. But for the sake of simplicity, I'm going to make c bigger than 6. So when I can take d away from it, I'm going to get 6. So let's say c was 8. If c was 8, then that is bigger than 4, isn't it? It meets this criteria here. Okay, and then so c minus d would be 6. So 8 take away, what would be 6? It would be 2, wouldn't it? So d could be 2. So if I've got c is equal to 8 and d is equal to 2, it meets both those conditions. C is bigger than 4 because it's 8. D is less than 4 because it's 2. And c minus d is equal to 6. 8 take away 2 is 6. So it works, doesn't it? Now there are lots of other examples. You could have had c is equal to 9 and d is equal to 3. Or you could have c is equal to 7, d is equal to 1. That would also work. Now you can actually have negative 1s and 0s as well. You could have c is... No, you couldn't. Yeah, you could have c is equal to 6, d is equal to 0. I've given you 3 examples there. You don't even need 3, you just need one of them. So as soon as you found one, you can stop. So I'm going to go for 8 and 2. Part B says w is greater than 1 and less than 2. X is greater than 0 and less than 1. So these are kind of decimal numbers, aren't they? Work out a possible pair of values for w and x. Okay. So if I need to get to 2.6, now x needs to be reasonably big, doesn't it? Otherwise it's not going to get up to 2.6. Let's say it's like 0.9. Okay, so that's between 0 and 1. Then if I take 0.9 away from 2.6, I'm left with 1.7. And that lies between the range as well then, doesn't it? So work out a possible pair. I can go for w equals 1.7 and x equals 0.9. Now again, there are other possibilities. You could have had 1.8 and 0.8. They would work just as well. You only need to come up with a possible pair. You don't need to get all of them. And if yours is different from mine, as long as they meet those 3 conditions, you're going to get the marks. Question 13. Here are 3 straight lines. Are lines A, B, and C, D parallel? Tick a box, yes or no. Show working to support your answer. Well, I know already that they're not, and the reason I can tell is that these two angles are different. Okay, if they were parallel, then these two angles would have been the same, and they're not. Okay, so therefore they are not parallel. Okay, because if they were parallel, then this angle here would be the same as 95, because they would be corresponding angles, and that angle and that and the 105 would have to be equal because they're vertically opposite. Okay, so I'm going to say no, and I'm going to call this one, let's call that X. Okay, and I'm going to say if they were parallel, then X would be equal to 95, as it is a corresponding angle, but X is vertically opposite 105 degrees, so it should be equal to 105. I'm just going to say that this is a contradiction. This is a contradiction. And so the lines cannot be parallel. Okay, so I've written far too much here probably, but you know, it's worth 2 marks. I like to be thorough, but you'd probably get away with writing a fair bit less and still get both marks. Question 14, match the algebra to the correct description. One has been done for you. So we've got identity, formula, equation, inequality, expression. So the expression has already been done. Expressions don't have equal signs in them. Inequalities have inequality symbols, so I can see that one straight away. So I'm just going to match these two up while I'm here. It's quite an obvious one. And then what else have I got? I've got 5a equals 20, and I've got 2c plus c is equal to 3c. Now, both of them have got equal signs in, so you'd think they might be an equation. They're not a formula because they've only got one letter in them. So they're either an equation or an identity. Now, I'm going to say that 5a equals 20 is an equation, and and 2c plus c is equal to 3c is an identity. Now, the difference between an equation and an identity is that an identity is always true. So it doesn't really matter what the value of c is, it's going to be true. If c was 2, then 2c plus c would be 4 plus 2, and that's going to be equal to 3c, which is 6. But it would be equally true if c was 100 or c was 1000. Whereas 5a equals 20 is true when a is 4 and for no other value. Okay? So 5a equals 20 is an equation because it's only true for some values. 2c plus c is equal to 3c because it is an identity because it's true for all values. Question 15. Popcorn is sold in bags. 8 small bags have a total mass of 496 grams. 5 small bags and 2 large bags have a total mass of 638 grams. Work out the mass of a large bag. Okay. So I'm gonna form some equations here. I'm going to let S is going to be the mass of the small bag, and let's do L is the mass of a large bag. Okay, and then from there I can say 8 small bags have a mass of 496. I can write that as 8S equals 496 then, can't I? Okay, so that's my formula, so that's my equation there. And the second one, 5 small bags and 2 large bags have a total mass of 638 grams. I can say 5s plus 2l is equal to 638. Okay, so they're my two equations. I've got 8s equals 496, and I've got 5s plus 2l is equal to 638. So that's my equation 1 my equation 2 from the information I've been given. Now I can take equation 1 and solve it, can't I? So solving equation 1, 8s equals 496. Now if I just divide both sides by 8, what am I going to get? I'm going to get 496 divided by 8. That gives me 62. Okay, so dividing by 8, they'll cancel, leaving me with s equals 62. Okay, so I found s. Now I want to find L. So what I'm going to do is I'm going to substitute s equals 62 into equation 2, my second equation I've got. That's going to give me 5s, 5 lots of 62, plus 2l, that is equal to 638. Okay? What is 5 lots of 62? That's 310. So 310 plus 2l is 638. Let's just roll it up slightly. And so taking 310 away from both sides, that's going to leave me with 2l is equal to 638 minus 310, that's 328, isn't it? 328. So then L is going to be half of 328, and that's going to be 164 then, isn't it? So my large bag has a mass of 164, and my small bag has a mass of 62. I'm just going to put that in grams because that's what they are. Okay, so 62 grams and 164 grams. Question 16. The rectangle and the triangle have the same area. Work out the length of the rectangle. Okay, so let's start with the triangle because that one is complete. We've got everything we need to work out the area of a triangle. Area of a triangle is just half base height, isn't it? Which is a half times the base of this. The base is this line here. It's 12. So that's half times 12. And the height of this one is this line coming down here, isn't it? It's 16. Okay, so it's going to be half times 12 times 16. I'm just going to do half of 16. This is what I kind of halve one of the numbers and then just multiply. So 12 eighths then is 96. Okay, so that's going to be 96 centimeters squared. Alternatively, you could pick up a calculator and type it in. Okay, so then if I know that that's 96 and I know they're the same, then that's also going to have an area of 96 centimeters squared then. And so because I know that the area of a rectangle is length times width, and I know then that 96 is the area of the rectangle, and I know the width is 7.2, then I can find the length just by dividing both sides by 7.5. So if I divide by 7.5 and I divide by 7.5, they'll cancel and it'll leave me with the length. Okay, so what is the length then? It's just going to be 96 divided by 7.5, and that comes out to be 12.8. 12.8. And I guess that's in centimeters, isn't it? So L equals 12.8 centimeters. Okay. Question 17. Match the name to the correct sequence. One has been done for you. Oh, good. That's the hard one, the quadratic sequence. Linear sequence, that's easy. It just has a common difference. So it's going up in the same number each time. And a Fibonacci type sequence, you're adding the two previous numbers together to get the next one. Now I can see that that top one is Fibonacci because 4 plus 5, look, that's equal to 9. And 5 plus 9, that's equal to 14. And 9 plus 14, that's equal to 23, isn't it? So that one is definitely a Fibonacci type sequence. So I can put a ruler and join those two up. Handy, my ruler was already pointing in the right direction from last time. And then the linear sequence, now I'm just looking for the one with a common difference then. Now the difference with this one, this is add 4, add 4, add 4, add 4, so I can think it's that one. This one is add 3, add 2, add 4, add I don't know what. I don't even know what sort of sequence that is. That's a weird sequence. So yeah, it's going to be the nice one, not the weird one. It's going to be that one. I'm not going to dwell on what the other one is because I don't need to know. Got to move on, got an exam to do. The number of hedgehogs in England is expected to reduce by 4% each year, which is very sad. Assume that there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. You must show your working. Now this is a kind of compound interest question, isn't it? But it's actually what we call growth and decay, and in this case decay because it's going down rather than up. Okay, so I'm just going to start off with my triangle for percentages generally, FOM, but because it's compound interest I also include the number of years as well, and that's what I need to know to work this out. So the final, that is what I want then, isn't it? I want to know the expected number of hedgehogs in 5 years, so that's the final that I'm looking for. So that's the thing I'm trying to find. I don't know it at the moment. What's the original? So the original is the number of hedgehogs that are currently. So that is 1 million. And the multiplier, well, it's a reduction of 4% each year. So my multiplier, if I've got 100% and I subtract 4%, that leaves me with 96%, which is 0.96 as a multiplier. And then the number of years, how many years are we doing this with? We're doing it for 5 years, aren't we? So the number of years is going to be 5. Okay? So then, covering up the thing I want to find the final. It tells me what to do the other two. It's the original times the multiplier. So final equals original times multiplier, which is 1 million times by 0.96. And I'm going to raise that to the number of years, which is 5. Okay? So what is that then? 1 million times by 0.96 to the power of 5. That comes out to be 815372.6976, and I don't want a 0.69 of a hedgehog. I'm going to have to round it one way or the other. I think I'm going to round it up. So that is 815,373 hedgehogs. Okay, and then that's my answer. So 815373. Here is a cuboid. Cuboid B is made from 2 of cuboid A. Looks like they're stacked on top of each other. It says the volume of A to the volume of B is 1 to 2. Matthew says the surface area of A to the surface area of B must also be in 1 to 2 because B is made up of 2 lots of A. Is Matthew correct? No, he's not going to be correct, is he? And the reason for that is they have a shared face that gets lost in the middle of the cuboid, don't they? So if you think about it, you've got this extra kind of face that sits at the intersection of these two cubes. So the bottom face of the top cube and the top face of the bottom cube don't make make it into the surface area of the new shape. Okay, so overall then the surface area is not going to just be twice the one of the original cuboid. Okay, so face from each cube are joined and so do not form part of the surface area. Therefore, the surface area of the combined shape will be less than the surface area of the two separate cubes. Okay. Oh, I wrote cubes. It should be cuboid, I guess. Let's just change that. Make it a bit more accurate. So it should be cuboid, shouldn't it? They're not cubes. Cuboid. Cuboid. Okay. I think that will do. Complete the table of values for y equals x squared plus 2x. Okay, so we're going to use the table function on the calculator to work this out. So if I press home key and then go over to the table function, okay, you can see like I've got a blank table here at the moment. So the first thing I'm going to do is press the tools button and I'm going to put in the range. So I'm going to put my start value as -3 and my end value is 1. And you'll notice that we're going up in ones each time. So I'm going to put a step of 1. Okay? Right, so once that's in, you can see now that the table has got the values from -3 to 1 in the first column, but we don't have the y values yet. So I'm going to press the tools button again, and I'm going to go down to define f of x, g of x. I'm just going to define f of x because I only want one function, and I'm going to type in x squared plus 2x. Okay? So now when I execute, you'll see that the second column is then filled up and it's going to give me the numbers that I need. So I'm going to get 3, 0. So I'll put that one in there. Then -1, which matches, 0, which matches, and then I'm going to get another 3 on the end, aren't I? Okay? So that's my complete table. Right, then next up I need to plot those on the graph. So -3 goes with 3, so I'm going to put a little cross there. -2 goes with 0. There, look. -1 goes with -1. That's the lowest point on the graph. And it starts going up again, 0, 0, and then 1, 3. So you can see I've got that parabolic shape that I'm expecting from a quadratic graph. Join them up with a nice smooth curve. Taking care to just use one line and passing through each point. Okay, that'll do, I think. So it's like a parabola shape. Yeah, nice. That'll do. Jing has £2,450. She saves some and gives the rest to her 4 brothers. The ratio of money saved to money given to her brothers is in the ratio of 2 to 5. She gives each of her 4 brothers the same amount. Does each brother receive more than £430? You must show your working. Okay. So first up, we want to know how much Jing gives to her brothers in total, and then we can see if we can split that 4 ways and then see if and compare it to the 430 we've been given. So let's have a look at this ratio here to start with. I've got the ratio of 2 to 5, so that means that Jing keeps 2 shares and gives 5 shares away. So altogether, that's 2 plus 5, that's 7 shares, isn't it? So now we know the number of shares, we can work out the value of each share because we've got £2,450 to start with. So if I take that and I divide it by the number of shares, so if I divide that by 7, what's that going to be equal to? So 2450 divided by 7. That comes out to be 350. So that means each share is worth 350. Okay, so the ratio of Jing, what she keeps to what she gives to her brothers, is in the ratio of 2 to 5. And what we're going to do is we're going to say that each one of those shares is worth 350. So if we take that ratio and we multiply it up by a factor of 350, okay, times by 350 both sides, because that's what we worked out the value of each share was. Then 2 lots of 350, that's just 700, and 5 lots of 350, what's that going to be, 1400 and another 350, that's 1750 then. Okay, and so the amount of money that we give to the brothers is that one there, then it's the £1,740, that's what's going to her brothers. So brothers receive £1,750. So each brother is going to get 1750 divided by 4 then, aren't they? So if I take that 1750 and divide it by 4, I get £437.50. £437.50. pence. Okay, so does each brother receive more than £430? Yes, each brother gets more than £430 then. Okay, so remember to answer the question at the end. Right, I think we're done. And the pie chart shows information about people at a fair during 3 days. Okay, and then it says over here not drawn accurately, so you're not going to be able to measure this with your protractor. But they do give us two angles inside the circle. We've got the Thursday amount represents 25%, Friday was 80%, and Saturday is the rest. Now it says there were 132 more people on Friday than on Thursday. Then work out the number of people there were on Saturday. Okay. Right, so what we need to do here, we need to work out the angle for Saturday, and we need to know the relationship between the angle and the number of people. So we need to know those two things in order to answer this question. Now the first thing is fairly easy because I know that angles meeting at a point add up to 360. So those three angles there, if I call that one x, then 25 plus 80 plus x is going to be equal to 360, the number of angles in a full turn. So 25 and 80 together is 105, so that's 105 plus x is 360, and then taking 105 away from both sides, I can see that's 255 degrees. Okay, so that's 255 there, then, isn't it? 255. Now, so that's the first part of the problem. Now, the next part of the problem is working out what that angle represents in terms of actual people. Now, we know that there were 132 more people on Friday than on Thursday. So that 132 more people must be represented by the extra angle that you've got on Friday that you don't have on Thursday. So if you take the extra people on Friday, it's going to be the difference between those two angles. It's going to be represented by the difference between those two angles. So if I do 80 minus 25, we can see that those extra people must be represented by that extra 55 degrees in the Friday sector compared to the Thursday sector. Okay, so if 55 degrees goes with 132 people, so degrees to people as a ratio is like 55 to 132, then what we want 255, don't we? We want to know how many people are represented by 255 degrees. Okay, so I'm going to use the unitary method, go via 1. So if I divide through by 55 and then times by 255, I can go from 55 degrees to 255 degrees. So doing the same thing with the people, so dividing through by 55 and then timesing it by 255, I should know how many people that represents then. So 132 divided by 55 times by 255, that gives me 612. Okay, it's not really that necessary to write the number in between. That's not really what we're interested in. We're just kind of using the unitary method of this idea of going via 1. We don't really need to know how many people 1 degree represents, so I didn't bother writing that down. I just kind of skipped it and went straight to the number of people represented by 255, which is 612 people. So the number of people on Saturday, 612 people is the answer. Use trigonometry to work out the value of x. So I'm going to be using SOHCAHTOA, free trig ratios for right angled triangles. So SOHCAHTOA is a good way of remembering which ratio to use. Now before I work out which one I need, let me label up the sides of the triangle. So I always start with the hypotenuse. It's always the longest side, so that one is there. It's the one opposite the right angle. Then this 46 is next to the angle given, 58, so this one must be the adjacent, and the x is on the opposite side of the triangle to the angle, so that one is the opposite. Okay, so having a look at which ones I've got, which ones I want to find, or alternatively, which one I don't have and I don't want to find, is I often find it's easier to deal with the one that I don't want. So I don't want H, so the ratios with H in, so that's SO has got a H in it, Ka has got a H in it. It's going to have to be this one on the end, isn't it, the TOA. Okay, so I'm going to be using tan for this one. So I'm going to write out the full trigonometric ratio for tan. So tan theta is equal to the opposite over the adjacent. That's what TOA means. And then we're going to sub into that then, aren't we? So what's the angle first up? Well, the angle is 58. So theta is the placeholder for the angle. So let's replace theta with 58. Is equal to the opposite. Now the opposite is the x down here then, isn't it? So that's going to be x divided by the adjacent. Now where's the adjacent? It's up here. It's the 46. So that's going to be tan 58 equals x over 46. Okay, rearranging for x. Just cross multiplying that 46. I'm going to get 46 tan 58 is equal to x. So then typing that into the calculator, 46 tan 58, that comes out to be 73.6. 73.6, so x equals 73.6. It's going to be in centimeters, isn't it? Okay. Before I move on, I just need to think, well, is that answer sensible? It's quite a bit longer than the other one I've got of 46, but I've got a wide angle there at the top, so you are expecting the x to be bigger than 46, so I think it looks okay. I'm going to go with that, 73.6. Millie is estimating the value of 1 over the cube root of 8.34 all squared times 10.21. She rounds each number to a one significant figure. Work out Millie's estimate. You must show your working. Okay. So rounding each one of these off to one significant figure, I'm going to get, well, 1 is just 1. I'm going to get the cube root of, well, 8.34 to the nearest whole number is going to be 8 squared times, and 10.21 to the nearest 10 is just going to be 10, isn't it? Okay. So then let's work out what that is. Well, the cube root of 8 is 2. So I'm going to get 2 squared times 10, and 2 squared is 4 times 10 is 1 over 40 then, isn't it? So I'm going to get 1 over 40. Part B says, Millie says, my estimate must be more than the exact value. Without working out the exact value, give a reason why she can know this. Right, well, if you have a look at what happened to the numbers, this number down here got rounded down, and this one here got rounded down. So this is smaller than it was, and this is smaller than it was. So then I multiplied those two together, and that's going to give me a smaller denominator than I would have had. And then dividing through by a small denominator is going to give me a larger answer. Okay, so I can say you can know this because the numbers in the denominator were both rounded down, giving a smaller denominator overall, dividing through by a smaller denominator would give a larger final answer. Okay, I think that's it. There's only worth 1 mark. I mean, I've already written an essay. I think that's fine. I'm not writing anymore. 25a, factorize x squared plus 8x plus 15. Okay, now this is a quadratic, and I know that quadratics normally factorize into 2 brackets if they're going to factorize. Now this starts with x squared, so I'm going to have x and x inside my brackets there and there, because x times x is x squared. And I can see I've got plus and plus in my quadratic, so I'm going to have plus and plus inside my brackets too. And then in the end here, look, I've got a 15. So I need to think about what are the factor pairs of 15. So 15 has factor pairs 1 and 15 and 3 and 5. Now I'm looking for a factor pair that adds up to 8. So what's my factor pair that adds up to 8 then? Well, 1 and 15 makes 16, but 3 and 5 add up to 8. So it's going to be x plus 3, x plus 5 there. That's going to be my factor pair that adds up to 8. Okay, so that's it then. X plus 3, x plus 5. And then 25b says, write down two solutions of y plus 2 times y minus 4 is equal to 0. Okay. Well, if I've got two things and I multiply them together and I get 0, that must mean that one of the things was 0 to start with, because something, you can only get 0 if one of the things is 0 that you multiply, isn't it? So that means that y plus 2 must be equal to 0, or it means that y minus 4 must be equal to 0. One of those two things could be the case. Now, if y plus 2 is equal to 0, that means y must be equal to minus 2, or if y minus 4 is equal to 0, that means y must be equal to 4, then rearranging those two. Okay, I think we are done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.